Alors, j'ai vu une autre auto, une Mazda
Je
6.
t'entends. Ouais.
Je crois que c'est une 2016
Mhm.
bleue.
So one of the nice things about having a full house is that we have a full house, but it also takes a while to get it started. So welcome. My name is David Alexander. I'm the director of the Space Institute. I think I recognize a lot of faces. How many of you, this is your first Spaceport lecture? Wow. Well, welcome. This has been. I've been really proud of this series. We've had some great speakers, and I think at the end of tonight you'll agree that we've kept that condition going, or that going. I have a couple of little quick announcements to make before we start this evening's process. We will be having another speaker in October. And again in November. I'm still refining a couple of the dates just to make sure, so I don't want to announce anything just in case. But please look at the website, rsi.rice.edu. You can follow us on Twitter at RiceSpace. We have a Facebook page and all the usual stuff, right? And if you haven't signed up for the Spaceport Lecture mailing list, please do so. You can contact us through spacefrontiers.rice.edu. All we ever use that mailing list for is to tell you about these talks. So there's no other, we'll not be sending you solicitations for money or, Nigerian bank accounts or anything like that. A couple of things I'd like to say. For those, how many students are here? Fantastic. We have a fairly recent addition to what we're trying to do at the Space Institute, which is we now have a RICE chapter of the Students for the Exploration and Development of Space, which is something like 40-something chapters across the world, mostly in the US and North America. Anthony Scola and Andrew Gatherer over here are the people to talk to if you'd like to learn more about what's going on at RICE and how the students are getting involved. We've had a couple of changes in the RICE Space Institute. I'd like to introduce Treasure Wilson. Treasure is the one who helped prepare all the food and get it all set up. I stand up here and take all the credit that everybody knows all the work's done by the other people. Prior to Treasure, of course, you all know Lindy Cantu. There's been a couple of administrative changes in the department. And I couldn't have done almost anything I've tried to do without everybody's help, so thanks a lot. Let's see. The theme of tonight is going to be exploration, and so I have a little pop quiz for you. Anybody know what tomorrow is? Don't say Thursday, please. Tomorrow is the 50th anniversary of the very first episode of Star Trek. And so that sets the exploration theme, and we're going to continue that with our speaker tonight. So let me introduce that. So I have to do this, right? We'll now boldly go on and introduce our speaker. Everybody who knows me knows my jokes. That's as good as they get. Okay, so this is someone that when Dava got appointed to her current position, I think a lot of us in the community were really, really excited. Really top-notch engineer, knows what she's doing, apart from the fact that she moved to Washington, D.C. But really excited because I think NASA has got lots of great people, and just seeing them pull in some of the top talent from academia is really great to see. So we're really excited, and so ever since that, she's been on my list to try and get her as a speaker, and we kind of managed to work it out, and I'm really grateful for that. So Dr. Dava Newman was nominated by President Barack Obama in January 2015 and confirmed by the US Senate in April 2015 to serve as the Deputy Administrator of the National Aeronautics and Space Administration, we all know that is NASA, and she's been on the job for about 18 months or a little bit less. Prior to that, Dava was the Apollo Program Professor of Astronautics at MIT. This is a small university up in the Boston area. I have to say though, whenever Rice is thinking about doing something new, it's like, let's go see how to do it at MIT first. So that's a nod to our engineering team over there too. Her expertise is multidisciplinary research that encompasses aerospace biomedical engineering. Her latest research efforts include advanced spacesuit design, dynamics and control of astronaut motion, socio-technical systems analysis and space policy, and assisted and wearable technology. So that's really some really cool areas. She's the author of Interactive Aerospace Engineering and Design, which is an introductory textbook published by McGraw-Hill, and she's published more than 250 papers in journal and referee conferences. She's also served in numerous National Academy studies and panels, and her bio goes on and on and on. I will stop there and ask you to join me in welcome tonight's speaker, David Newman.
Thank you. How's everyone doing? It is my great pleasure to be here. Everyone can see, okay, I don't fall asleep. Because we're gonna take a journey. So why explore? We have enduring questions. Are we alone? Are there other habitable planets? And on Mars in particular, was there past life? So those are the questions that they keep me up at night, and that's what NASA's all about. It's really thinking about those enduring questions. So raise your hand if you're 26 or younger. There's a majority, thank you, shout out. Your entire lives, our Hubble Space Telescope, the world's greatest optical telescope, has been peering in to the solar system. Now it's in low Earth orbit, so it's not too far up, right? But the story, there's so many stories about Hubble, but the one I like to tell is that if you put your thumb up, your thumbnail, right? There's a really dark spot in the sky that had never been observed. So what did we do? We basically asked Hubble to take a long exposure image of that, 10 hours looking at that dark spot. Anyone know what we found? 3,000 new galaxies. 3,000 new galaxies. You know, something as big as your thumbnail. So it's kind of a gift that just keeps on giving. I love Hubble, and it's just amazing. It wasn't easy. We had to, do some repair missions, but I think it was definitely worth the investment, especially for the scientific return. So I'm going to go through who was with us. This is when I started at NASA, right? Pluto counts a dwarf planet. I count dwarf planets. That's a heart. I love that about Pluto. We hadn't seen Pluto, right? To this resolution. Every single day today, we're still getting new images, and analyzing them from our Pluto flyby. So New Horizons, right? 30 years in the making, a 9-year mission. So that's kind of what spaceflight's about. Where it's not for the faint of heart, but when we can unravel kind of the mysteries of the universe, and just simply ask, where did we come from? I like to ask where we're going as well. I don't know if you've heard of Dawn spacecraft, but again, I want to tell you about Dawn. This is, we're the real Martians. This is real technology. It is an ion-propelled spacecraft that is Dawn. It actually went out to 2 planets, Ceres being the one that we're looking at now, the dwarf planet Ceres. And those particular shiny eyes, if you look at them, we didn't know what they were. Kind of zoomed in. We got about 400 kilometers up, and Ahuna Mons. Turns out that this is one huge mountain. Move over, Mount Everest is 20 kilometers wide in diameter, about 5 kilometers high. And well, what's shining at us? What's looking at? We definitely have the evidence for some sodium carbonates. You should be saying, wow, that's really exciting. Why? Because we're looking for the evidence of life, the possibility of life. These are signatures. These are signature chemical compositions. So we're looking all over the universe for things like that, and then exploring who would have known, again, in a dwarf planet. And what'd you do on July 4th? The U.S. had a huge birthday party for us. We got to Jupiter. So I hope you were with us with the Juno mission. It's really unbelievable. The largest solar-powered spacecraft that's ever flown throughout the solar system to Jupiter. We're in orbit. And Juno Cam is what I'd like to tell people about, because it's our largest effort in citizen science. Hey world, where do you want us to look? Jupiter is incredibly fascinating, but now we point Juno Cam wherever you tell us to point it. And it's open to the world, because that's what we're about. Now, it's in a pretty hairy orbit. That's an elliptical orbit. Now we zoom over the poles and zoom right back out, because this is a huge radiation environment. Just a couple days ago, last week, we turned on all the advanced science instruments. So we're getting data back from our science instruments now, because they survived the launch. Again, the trip out was launched in 2011, planned it, to be at the closest and go into orbit on July 4th so we can celebrate. But it's amazing. It's going to be amazing what science comes back from Juno. All right, how many have heard about exoplanets? I know there's a couple of PhD students in the room studying them, so they have to teach me. But I had to show these out. This is, again, shout out to the artists. We haven't seen them. We have the evidence of them, but what do they look like? So we have a lot of fun, actually, looking at, 51 Peg B, the first exoplanet, and then Kepler 16b. Sure enough, we have found an exoplanet that is a binary sun planet, two suns. Other ones, literally there's thousands of exoplanets. We put out 1,200 up in a catalog, and there's about a couple dozen that we call they're in the sweet spot, maybe the habitable zone. Now, these are too far to get to, but again, 20 years ago, there wasn't a field of exoplanet science. Right now, 20 years later, we've found thousands and thousands. Again, we're looking for, habitable Earth-like. There's one that doesn't have a sun as well. So just amazing, amazing, again, what we're finding. So James Webb Space Telescope, James Webb is 18 articulating controlled mirrors. Dr. Mather, our Nobel laureate at NASA, tells me it's 100 times more powerful than Hubble. Now this is an infrared. This is an infrared telescope. We will launch it in 2018. We'll launch it in 2018. This is what it looks like today. The mirrors are truly amazing. It's going to come down to Johnson Space Center early next year in 2017 to do our final thermal back testing, and then it's going to get to Southern California and on a boat to French Guiana. It's going to be launched on an Ariane 5. Okay. I know it's the 50th anniversary of Star Trek, but more important, tomorrow is going to be the launch of OSIRIS-REx. So we're going to an asteroid, Bennu, and going to take a sample. So our first asteroid sample return mission. So it's incredibly awesome. It's great for launch. Literally 7:05 tomorrow night. I guess 7:05 Eastern. So we'll have launched by now. Really, really exciting. Again, this asteroid mission. Incredible science. Okay. Now, I'm going to tell you a little bit about our journey to Mars as well after a lot of those shout-outs again. Just out of 100 science missions, I've just only picked, a half a dozen highlights to tell you about what's so fun about my job, what I get to learn about every day. We've been at Mars for the last 50 years. We've been on Mars for the last 50 years. So I want to show you this video just in recognition of how much exploring and how much knowledge we already have about Mars.
The extraordinary men and women of NASA in our Jet Propulsion Laboratory. Right now, the wheels of curiosity have begun to blaze the trail for human footprints on Mars.
I just wanted to call and say congratulations to the entire Mars Science Laboratory team and really all of JPL. You guys should be remarkably proud.
Get humans to Mars in the 2030s. everyone we work with. So latest data, we actually have found flowing water, very, very briny, very high salinity. Can't drink it for humans, but it's seasonal. So we have 5 assets on Mars today, rovers and orbiters, and we're studying this. We knew that there was ice on the poles, but after this discovery, we're zooming in to try to look at the seasonal changes and actually looking at the flow and seasons of water. It's better. Also have the first evidence, the first papers have now been written on how Mars lost its atmosphere. Earth and Mars, 4.5 billion years old each. Mars today has a 1% carbon dioxide atmosphere. Mars doesn't have a magnetic global shield. Earth does, thank goodness. Mars not so lucky. So we see the solar wind and radiation literally ablating the Martian atmosphere away. So there's the first evidence of literally seeing the ions coming off the Martian surface to leave us where we are today from our Maven spacecraft. Again, every day we get data like this, we're learning more about Mars every day with our rovers and our orbiters. We do have a plan to get some journey to Mars. We are charged by the President to send humans out, first to Earth-Moon orbit and then to Mars, and to get humans, and this will be hopefully if we can sustain this and keep the momentum going. I like to explain it in 3 phases. Show you this chart. So the 3 phases are where we're at right now today. We'll talk a little bit more about this, but on the International Space Station, that's phase 1. We've been 16 years. Anyone in here 16 or under? There's a few folks. All right, your entire lifetimes, 24/7, we've had astronauts living and working on the International Space Station. 5 partner nations with 15 different nations. We're all in. There's been over 200 folks living and working on Space Station. And what are we doing? Well, we're looking at human health, the astronaut health. We're looking at technology demonstrations. So phase 1 on our journey to Mars. But we need to move beyond low Earth orbit. So we're building a space launch system, which is huge. I'm going to show it to you in a minute. But that's phase 2, the proving ground. We get back out to lunar orbit, and we buy down the kind of technologies we don't have today. We have a list of 85, but the high priority ones are in-space propulsion, solar electric propulsion that we need. Life support systems, completely closed loop life support systems. We need deep space habitats. And the list goes on. So these are things we need to invest in and buy down and prove when we get out to Earth-Moon orbit, robotic technologies as well. And then phase 3. Phase 3 is getting to Mars in the 2030s, Mars orbit, and then finally humans on the Martian surface. These are little icons, these elements that we're investing in. And the other really important point is global exploration. We're saying this is what NASA's leading, investing in. Come on, world, what do you want to do? Because we have so many partners. We have everyone wanting to work with us. Again, which elements do you want to contribute? How do you want to work with us? So that's what our plan looks down. I'll tell you a little bit more again about the amazing work that's gone on Space Station after 16 years. You might have heard of Scott Kelly's mission. I sure hope you did. 1 year in space, and he's with his colleague Mikhail Kornienko from the Russian side, and we're doing the first, we got a chance to do the first genetics, the first DNA genetics experiment, because Scott and his twin brother Mark, former astronaut, down here on Earth. And so it's really incredible. Those results are just starting to come back. Waited till Scott landed so that we could really take a look at, again, some of these changes, some of the genetics. Each astronaut, during the 6-month, it's a typical 6-month mission, we do about 250 science experiments. During Scott's mission, since he was there for a year, we did over 400 science experiments. Here's a little, I asked him technology question. Okay, Scott, you've been up there. What technology do you think we need to invest in? What do we need to buy down for our next phase, for phase 2, when we get out to lunar orbit? And so here's his answer. I think you'll be able to hear it.
I think the life support systems that we need to keep us alive in space are ideal candidates for demonstrations for our future journey to Mars, as well as spacesuits. We need, I think, new spacesuit technology that requires less maintenance in space, and something that's going to be easier to work in on the surface under the Martian gravity.
So, funny story. Now, I do have a background in spacesuits and life support, so we don't know if he's biased, but it's great to get that feedback. So, after an EVA, extracurricular activity, they're in the spacesuits, and so Scott actually was with his colleagues up there, and so they called me at NASA headquarters, right? I was in a meeting, so, oh, Johnson Space Center is calling his 713 exchange, right? But I was in a meeting, so, okay, well, I'll have to call him back. Never, no, I know, so I get done with my meeting, I'm like, I can't believe it. Scott just called from the space station and I let him go to the message machine. So I pay more attention. 713, but if it ends at 1000, it's like, oh, wait a minute, it might be from a space station, it might not be Houston calling. So I learned my lesson. And here we have a PhD student here in anthropology, interested in veggie. So again, the human factor, there's nothing like growing, harvesting, and eating something fresh in space. You're up there a long time. It's like a really long camping trip. So here you see Scott and Michelle Lundgren with their Japanese colleague kind of celebrating and having some fresh lettuce and salad in space. Now here's just some of my kind of favorite technologies, if you will. What are we doing? A space station truly is the world's greatest orbiting laboratory, and we're looking at the technologies again. What do we need to do to get to Mars? And what are the technologies that we can use as a laboratory? We've got technology demonstrations. What do we need to buy down in terms of our technology risks? So here's everything from refueling to halves to humanoid robotics to fire and safety in space manufacturing. We have our third version actually of a 3D printer flying today. It's fantastic. ABS works well, right? How many of you are makers? 3D printing, interested in it, have made something? Not too many, not as many as I thought. Well, I think we have a new generation, of folks, of makers thinking, and now for the first time, oh, you need a wrench? Guess what? We don't have to fly all that up there. We can actually make one on station to help do repairs and things like that. So it's really been amazing to be able to make it while you're in orbit. It's really phenomenal. And also, I call it the new NASA, if you will. I have the great fortune to be in charge of over 700 of all of our partnerships. We work with 120 nations around the world, and our public-private partnerships are critically important. We're doing business in a new way. A little bit about the technology, but it's really about doing business in a new way, paying for services. So we're paying for cargo services to be delivered to space station, and in the future, for our astronauts, for commercial crew. So we're counting on SpaceX, and I have ATK up here as well. We just put a third company in terms of phase 2. Space station will be on until 2024. So we also have Sierra Nevada Corporation. So they'll all be delivering cargo to space station, buying those services, and then in the future, SpaceX and Boeing will be delivering our astronauts, and we'll return the launches to the U.S. I have the Russian Soyuz as well, delivers both crew and cargo, and then the Japanese cargo, HTV. So again, we're all in this together. We're all dependent on one another, and they're incredible partnerships of working together, kind of through thick and thin. Okay, so how many of you know about our Space Launch System? Pretty many. Well, not everyone, so I got to tell you a little bit more about it. It's really amazing. I think the video shows it even better. But Saturn V, I think I'm here because I was inspired by the Apollo program, Apollo 11. We could do anything, and we could get to the moon. Well, now we truly can get back to the moon and Mars, and this is a vehicle that's going to take us there. system with Orion on top. 2018, we'll be launching SLS, not with astronauts for the first mission, on Exploration Mission 2 in the early 2020s launching. This is 1,000 US companies across all 50 states have a piece of and are working on the space launch system. So it's pretty amazing. Again, more powerful than the Saturn V. So it's been a long time coming, but we will have heavy lift launch capability back. And so I can't wait. Well, I showed you a video. What I can tell you is those are the successful Mars rovers and landers. So here's kind of an infographic, if you will, the entire history of trying to get to Mars. It's hard. It's far away. But we've learned a lot. So truth in advertising from the 60s, and it's by a country that has tried, first we just tried to, fly by. And then how about orbiters? And how about landers? But what I've highlighted here, since the 2000, look at all those green checks. Incredible success. The latest, the Indian Space Agency, first attempt, have an orbiter, MOM. I love the acronym. MOM's in orbit. We work with them. Incredible success for Indian Space Agency, but we give them our deep space network. Give them navigation. We want everyone to succeed. When one succeeds, we all succeed. Again, this is global exploration, so we want everyone to succeed. We won't succeed every time, but as many times as we can. We have the ExoMars, that's the European mission en route to Mars today. And you saw the video. And then Mars 2020, first we'll do InSight as our next Mars launch. That'll be 2018, and then Mars 2020 rover. So again, to take a look at it, to truth in advertising, how hard it is, but again, the success, and we all can learn and work together and hopefully accomplish what we really set out. Now, in the 2020s, we'll have Space Launch System and Orion. We'll be in Earth lunar. We call that cislunar, to look at those technologies, buy down those technology demonstrations, get a handle on those. In the meantime, in parallel, we'll still be on the Mars surface with the rovers. We call these are the robotic precursors. And it's kind of a look at all the kind of high priority technologies, advanced entry, descent, and landing. EDL, you saw that in the video. That's really tough. It's really, really hard. We know how to do it for 1, maybe 2 metric tons. You've seen in the video, we've tried to land every which way as possible. Cranes and balloons and every which way. 1 to 2 metric tons, that's what we can do today. Pretty impressive. For the human mission, 10 to 20 metric tons. I can tell you it's not linear and it doesn't scale. So we have to figure that out. So again, we have to figure this technology, how do we do entry, descent, and landing, for the human scale. And you can go around for in-situ resource utilization. All exploration in human history that's been successful has lived off the land. So we can't take everything with us. How do we, I give the challenge to the students. I told you about that. We have a maker in space, which is great, right? On space station, on Mars. You need to make the maker. You get to make the maker out of the regolith of Mars. That's the challenge for you. Make the maker and we'll use it. So that's how we have to think about it, in terms of what can we use, how do we get there, what do we bring with us. So these are all the things that we can work on in the 20s. Again, in terms of technologies and capabilities. And we want to kind of highlight, do have a good model from International Space Station. It won't be exactly the same, but again, just with the point, the world does, humanity and the world wants to go to Mars. So what we're saying is we want to lead, we're stepping up to say that come join us. And what do other folks want to do? So we all the space agencies participate in developing the global exploration roadmap. Again, what can we do? And that includes from Earth to low Earth orbit to the Moon and to Mars. We'll meet next. Some of you might be going to the IAC, our International Astronautical Congress, is coming up now in September in Guadalajara, Mexico. So next time we get to all get together, and talk about it. About our journey to Mars and what all the other space agencies are doing. I'm an aerospace engineer, so I have to give a shout out to airplanes, or I wouldn't be a complete talk. So the future of flight. Now, when we invest, we are back in the X-plane era. It's been over a decade, too long, much too long, but we're back. The top plane, that's a low boom supersonic demonstrator. Low boom meaning a thud. Why don't we have supersonic flight over the continental U.S.? We have the technology, so we go 1.5, go Mach 1.5 or 2, that's what we want to do, but we had to get the shock down, we had to get the boom down. Now we have it down to something literally like that. That doesn't break windows and shake houses. So we can do that. We need to put the research and development monies in and commercially then make this viable. So we're invested in X-planes. The first one out is a low boom supersonic demonstrator. The two in the middle, those are our ultra-efficient planes. So it's 50% fuel reduction and 50% noise reduction. You know, not this 1 to 2% drag reduction. 50%, that's the goal. 50% fuel reduction, 50% noise reduction. The bottom one is actually a hybrid electric plane. That one already has been let out too as an X-plane demonstrator, the phase 1 for hybrid electric. That thing has six electric motors on each wing, so 12 electric motors for that hybrid electric plane. So the future of aviation and flight, you know, is going to look something like this. And we're sure that if we can invest in research and technology just to help industry get to the next step, that they will be successful in commercializing some of these ideas. Pretty exciting. Other highlights, Cygnus is going up, a hurricane monitoring satellite that's going up still this year. 2017, our joint polar satellite system. JPSS is going up in 17. Other missions are going as well. 2018, I wanted to give a shout out. I'm here with some space scientists and heliophysicists and Solar Probe Plus, but you can see the cadence. We have mission after mission after mission. These are major missions that are on track, you know, on schedule, and now we have to make them real. I want to get close to the end of my comments here and come back to my favorite planet, the spaceship Earth, if I didn't mention that. Mars is number 2. My favorite planet is Earth. And so again, this is you're looking at the far side of the moon. You know, things like that. It's the far side of the moon. I want to tell you about this for our Discover mission. And it's really a space weather moon. That's how I describe it. Sun and Earth. There's this really fantastic point. Lagrangian points you might know about. Well, Discover mission is in Illinois. This is the Lagrangian point. It is really a gravity neutral position. So it's just hanging out. That's what it is. It's hanging out there, looking at the sun, you know, and looking at the solar winds and the solar radiation and space weather, and saying, "Hey, Earth, it's 1 million miles away, right? 1.6 million kilometers away. Hey, Earth, this is what's coming your way." So it's really our space weather balloon out there. Great example. And you get to see the epic camera. You get to download the app, and you get to see these beautiful images. It's my new screensaver. So we have 19 Earth observing satellites flying today. And I say we. So NASA, we design and build and fly, and we work with our sister partners. NOAA operates some, USGS, looking at climate, looking at sea temperature, looking at sea change, looking at the Earth. So these are, you'll see space station included in this because we have amazing Earth science experiments that we can fly now in space station and look down. So again, this is off the Earth, but we say for the Earth. This is our eyes on the Earth. So in a natural disaster, the fires that are going on right now, we can say, hey, we can get almost real-time data. An earthquake or some disaster happens around the world, we can try to get imagery. Use our resources again to help people out, not just disaster, but this data that we're taking is critically important. And I want to show you this animation for a century of climate data. Now, how about Celsius? Because I'm speaking international units, you need me to convert. That goes up to, blue is going to be 0 to 2 degrees below average. That'd be 4 degrees Fahrenheit. Up to red is going to be 2 degrees above, hotter than average, or 4 degrees Fahrenheit. You can raise your hand when you're born, because it's kind of fun. You don't have to, but I'll raise my hand when I'm born. So, turn of the century, World War I, World War II. Thank you for participating. There we go. All right, now the students are born. It's hot. 2015 was the hottest year on record. We have the data from 2016. We get monthly data. We have the data in through July. 6 out of 7 months have broken all records. So guess what my prediction is for 2016? And I want to talk to everyone here, but faculty and the students. STEM, I'm 100% in for STEM. I've dedicated my whole career to STEM issues, but I've changed the names, really very intentionally. I bring in the arts. Any students here interested in art and history, journalism? We need you. We need every single one of you because you're the storytellers. I'm talking about going to Mars in the 2030s. You need to paint the pictures. You need to tell the stories. That's how we bring humanity with us. So critically important. The arts are in. D for design, that's why I asked anyone, who does 3D printing? We do have a new generation of makers out there. So my message to them is, we need you. We need you to work with us. So we made STEM a thing, and I hear students too often, girls and boys say, well, STEM, well, that's not me. Well, we have to change the conversation. You don't have to be the best in math and physics and calculus. I know you guys students were, but you don't have to be the best. Change the conversation. I say, those are tools. Those are our tools. I'm an aerospace engineer. I use those tools. But you know what? I want to build and design and fly rockets and get to Mars. That's my passion. So I need these tools to do it with. But you have to be proficient, right? So if we change the conversation and say, don't weed anyone out. We said these weeder courses, when I went through engineering. We shouldn't have weeder courses. Anyone who wants to be an engineer, a scientist, you're in. As an academic, it's my job to make sure that you succeed. That you succeed, because this is what you love and want to do, then that's how we need to have the conversation. That we need you to succeed and work with us. And I'm also fascinated kind of the art science of solving problems. That's a very interesting axis. I think there's an engineering design similarity axis as well. So if we kind of look at it more holistically and get training in these areas, then I think we can solve those really audacious problems that we have in order to get humans to Mars. So that's my STEAM speech. But again, we're steamed. I'm steamed. We're not making progress. Not fast enough. Not quickly. We've been working on this, so we have to think about it in a different way. And then seem to make sure that we're inclusive. The conversation be inclusive to bring people in. And I'm going to end on again. Just NASA, we do really appreciate again all disciplines. And again, shout out to the artists who have painted our pictures from our very beginning for over 50 years. I think Earth is art. We actually have a book, Earth is Art. This is science as well. But again, science and Earth. Anyone know where this is in the world? Where? England. England? No. But thanks for playing. Okay, that was in Russia. Oh, that was in China, actually. Guess where this is? What? Canada? Canada, close, but it's in Algeria. All right, this one. How about this one? Someone will get this right. Smart student will get this right. Antarctica. Yeah, that's the Russian shell, right? Still incredibly beautiful, incredibly scientific. They go hand in hand. We can learn about it, we shouldn't get it, but it is just beautiful too. How about this? Go south a little bit, Houston? A little bit further south? Yeah, Peru. This is the Nazca lines from orbit. This is what we see. This is the real thing. These are the Nazca lines from orbit. Moving fast forward a little bit.
The moon.
No? There you go. The interpretation of the moon. And I want to give my last recent image. Hope you know, Hidden Figures came out yesterday. It's a book about our amazing pioneering women computers that all deserve a shout. It's an amazing book. I got to read it over the weekend. This is Katherine Johnson at 98 years old. One of the dozens and dozens of hundreds of NASA women who helped us get to the moon and calculated those orbits for John Glenn and Al Shepard and everyone else. So again, it's coming out. There's a movie. Yeah, the movie's coming out in January, but the book is fantastic and out now. So again, go to take a minute. And it was these are the heroes. These are my heroes. And this is, we've always had pioneers at NASA that go against all odds and really are the breakthrough folks. Incredible savant mathematician, Katherine Johnson, to this day. She's sharp as a whip. And President Obama gave her, very deservedly so, the Presidential Medal of Freedom, the highest honor that can be bestowed on anyone. So I say boots on Mars in the 2030s, and I'm going to leave time for questions, and I'm going to think I have some great imagery that no sound here. This is recent footage taken from Space Station, but we might turn up the lights a little bit because I'd love to take some of your questions. This is recent footage from our astronauts taken from Space Station over. Thank you very much.
We have lots of time for questions. I did forget to give a shout out to our friends in Hawaii again. Aloha. We have a group from the University of Hawaii who frequently pays attention to what we're doing here. Anthony has been valiantly trying to stream this. Hopefully they got it. So if you want to send questions, you can do it through the YouTube channel or through the Twitter feed at Right Space, and we'll try and answer your questions. Questions? Who would like to go first? Oh, two guys at the front. So I don't have the handheld because the batteries are done, so we're going to have to
Can you tell us what exactly NASA plans to do with the space station in 2024?
Well, right now we're getting all the partners on board. So 4 partners, 4 out of 5, have committed to 2024, including us, and we're working with the Europeans. So one step at a time. The Europeans will have their ministerial in December. We're hoping that they'll commit. We're working with them to 2024. Then we'll have everyone committed to the life of 2024. And then, that gives us 8 years. So we're planning. We're doing as much science, as much technology as we can. And then we have to think about a deorbit strategy as well, and what we might do with it. There's definitely a lot of use out of it that we can do, but we do have to plan ahead and think about the end of the International Space Station as well. We are betting on the private folks as well. We're working with them really closely. You might know, and we are really looking for, hoping and looking toward the commercialization of low Earth orbit as well. If it's been many attempts, we think it's here to stay. We're at the crossroads in terms of investing in. So if low Earth orbit is commercialized, especially for small sats and other things, then we'll say it's NASA's job to get on with exploration. We necessarily need to get on with exploration. It's a Moon orbit, and we get on to Mars.
Yeah, okay, you can hear me okay. So I just don't understand this complete rejection of cooperation with China. It doesn't make any sense. You have Culberson who outright says the FBI told me what to do and I won't work with China, and it's really focused. We're going to be massively reproducing all this technology that they're doing, and we need to work together. And the president seems to be opposed.
I get the question.
Yeah.
And help us, help us with that. We want exploration is global. It's global in nature. We think we have a great framework to work with all international partners. Whatnot. As you know, we're actually prevented by law, by Congress, but we still do. We can work with China on some elements of aviation. Really looking forward to collaborating them in traffic management, in other areas in terms of some earth sciences and things. So we do everything that we can, but we of course have to stay within what legally we're allowed to do. But again, we're saying, hey, the exploration is global, and so our mindset is in great demonstrations. Let's take Russia as a critical partner on International Space Station. We're one another, dependent on one another. We like that. Soft diplomacy. It's the best example I have in terms of U.S. and Russian relations, going back to this partnership. We started this, and we go back to Apollo-Soyuz. It always is about people and decisions and trying to work together. I was fortunate to work with the Russians for an experiment for 2 years, flying my experiment on the Mir space station. So with the engineering and the science, we work together famously. We still have to, again, work through this because, we're saying we do want to work with everyone in the world and all space agencies.
Couldn't Obama go around Congress for the China?
Congress sets the laws and we go by the law. But you live in Texas? Yeah. And you can vote?
Following on that, when does it become locked in with the strategy going to Mars by 2030? Come locked in and it doesn't go with the change in political winds of the administration?
Yeah, so it's just the question, I think, in case people on top of here, what does it become locked in the strategy going to Mars? Again, we have momentum. We're going to 3 phases. We are well into the first phase of our journey to Mars. We want to keep the momentum going. We want to keep course. Of course, there's different policies. There'll be many administrations to come and go. At NASA, actually, what we think about is just being excellent and making our milestones, hitting our milestones, and delivering on that. Because then the people, and I think the Congress and the White House will say, they're making their milestones. They're true to their word. So we just have to stay the course and keep the momentum on. That's my take on it. We have to perform. but we can make this a reality. And we have to look at it for the long term. We have annual budget cycles, but we're planning for decades out. But that's what we always do at NASA. You know, our missions are decade-long missions, so they need to stay the course because these investments are critical. And again, it's not PowerPoints and slides. You saw SLS. This rocket, 5 core segments are together, you know, being demonstrated. Orion is delivered at our Kennedy Space Center for the SLS mission, the exploration mission for 2018. So maybe when we send that up, people will believe it. But again, it's way beyond the development. We're under more development at NASA now with SLS than we've been for decades, and we've been for decades. So thanks for that question.
Can you comment on some of the technologies and materials that are being developed from this
Yeah, absolutely. The technologies and the materials. So thank you. That's a great area to think about. Let's say NASA unique technologies and our high priority technology in space propulsion is really important to us. And so we're looking at, right now our major investments are in solar electric propulsion. And that's not for humans. How many saw The Martian? Okay, well, the technology was great in there, but there was only equivalent with about 3 things. And one of them was, solar electric propulsion. And that's great, but to move large masses, but slowly. So I want to send humans on the quick trip out, if you will. We need to so thinking about sending carbon and things like that in space propulsion, solar electric propulsion. We make more modest investments in terms of other propulsion techniques, advanced propulsion, in terms of some of the nuclear or some of the fast energies. Those are more modest investments we make in advanced propulsion. As I said, the life support systems, we have to close the loops on space station today. We have air loops and water loops. For Mars, they need to be 100% closed. They're 65 to 85% of our systems right now. So that's what we do in the proving ground. That's when we move out, we demonstrate these in a realistic environment, deep space. Earth, Moon, beyond Moon is deep space. We need to demonstrate these technologies. Deep space habitats. Again, it's not going to be like, it's not version, International Space Station version 2. Right? We're looking at something much smaller, affordable, that fits, again, it has to be affordable within our budgets and the current constraints that we have. We have to demonstrate that. We have to demonstrate that in deep space. So those are some of the top technologies that we're investing right now. We mentioned materials as well. Materials and materials. So again, we have a lot of intra-agency work going on as well. We have to think about what the materials are that are kind of space specific, because so much great work is being done in other agencies, other federal governments. So we have a lot of agency partnerships and things like that. We try to pay attention to what's happening in materials. We do some of our own work there. But again, that's more of a partnering situation. We're seeing and calling the universities what's out there that's kind of the best ones. And then we do some unique composites we're working on right now. Again, if it has to do with propulsion or some of our structures and things like that. But we're looking at things a little different. So those investments in terms of some of the advanced materials we're investing in as well.
Okay, I have to say I loved your speech.
Thanks. That's the only vote of confidence in here that I really cared about.
And I have 2 questions. One, are you working on trying to make the water on Mars so it is drinkable for human life?
Okay, that's your first question? Okay, so we have to think about that. Again, that's actually, so right now it's so toxic, if you will, because of the hot, it's really, really salty, so you couldn't drink it, for instance. So we have to think about that. Well, what can we do? Are there ways to make it drinkable for humans? On the Mars 2020 rover that you saw in my videos, we're going to actually make oxygen on Mars. First time we're going to ever make. Now, Mars is a carbon dioxide atmosphere, okay? It's light, only 1%. It's a carbon dioxide atmosphere. So there's an experiment on Mars 2020. It's called MOXIE. And what it does is it's going to split off the carbon atoms of this CO2 atmosphere. It's going to split off those carbon atoms. What are we left with? O2. So that's going to be the first demonstration of making oxygen on another planet. Now, it's not enough for a human to breathe yet. It's just the first demonstration. But if we can do that on Mars 2020, guess what we can do in the future? So we kind of do this, step by step to see what about the oxygen, and then how do we make water as well. Now, there's fuel cells are a technology that actually we use right now on space stations today. And the great thing is kind of byproduct, and we get a lot of water from those. So that's a great technology that it helps our astronauts today in making water up in space.
And my second question is, how will you improve your spacesuits from when the last rocket landed to be able to keep the people alive on Mars?
Yeah. So that's, because you probably saw The Martian, and so, they didn't have it all planned out. First of all, we're going to do a round trip mission. That's really important. We're going to bring the people home because you're going to be, you are the Mars, you're my Mars generation. If you're in school today all the way up through college, I call you the Mars generation. And so we're not going to strand you there. We're going to bring you home. And you know where the helmet and you kind of cracked and put duct tape on it? I love duct tape. I've used duct tape on every one of my experiments. But duct tape's not strong enough because that's a pressurized helmet, so that was, a little bit Hollywood. But again, what are we going to do? Well, we need habitats, right? So, and again, we need to bring some infrastructure with us, right? So if we go there, we have habitats. Guess what else we need? Fuel. It'd be a really good thing if we know that we have fuel for this round trip mission. If we have habitats already in place, so when we're confident that we have some of that infrastructure, then we can send the astronauts. Okay? We can be in orbit first, but then we send the astronauts. But we want to make sure that they're going to have a habitat when we land. They're not just going to have to live in the suit. The suit's a good temporary life support system, but that's to go out exploring. You remember your job when you were a Martian astronaut in the suit? They didn't do that very well in the Martian. It's a great book, I loved it, but they didn't tell you what the problem was. Going to search for the past evidence of life. Life that might have been there 3.5 billion years ago. But we have the evidence mounting that we will find. It's like being a fossil hunter. So you get to Mars, you're going to be a fossil hunter in the suit. But we'll have some habitats for you to live in as well, okay? When you find that fossil, we're going to scream and yell and celebrate it, because that tells us a lot about Earth. Whatever we find about Mars, our sister planet, that's going to tell us a lot about Earth as well, and the entire solar system formation.
Has there been any progress on the radiation problem traveling to Mars? I understand that nothing survives, basically.
So, well, no, that's not quite right. But the question is, what about the radiation environment? Yeah, the radiation environment for human health. So we have to, so we think of radiation protection. So how do we keep the astronauts healthy and well? And think about on the round trip there. There's a 3+ year total Mars mission. About 8 months or so to get to Mars. Basically, round trip of 2 years round trip. Hopefully, we'll be on Mars's surface for 600 days exploring. So on the round trip, let's call it roughly 2 years in getting there and back, as well as radiation on Mars. You have to think about it, each leg of the trip, if you will. So radiation protection on Mars Curiosity on MSL on our mission is currently there. There's an experiment called RAD. Turn it on as soon as we could after launch, and we measured the whole radiation environment traveling to Mars. And we'll keep doing that on all of our precursor missions. So we're learning. We're learning much more about what we have to protect against the radiation environment on there. When we get to Mars, then again, we have to think about shelters and again, how we can protect the people all the way to get them back. But right now, from a very early data in terms of radiation environment, we're comfortable going up to kind of getting your career dose, the career limit of radiation exposure. But again, we can keep it within those bounds. It's probably one trip mission to Mars. I mean, in terms of the crew. Probably don't get 2 trips because then you get exceed radiation. But it is the number one challenge that we work and think about. Also think about, since we have some time to think about it, think about protection, but also think we have to think about the biology of this as well, and the personalized medicine and everything that goes with that, right? So we have to think about it in new ways, because we do have the next decade to really think about it and make sure we can reduce this risk of radiation to get them back healthy and well.
Several more questions.
Thank you for the wonderful talk. I just had a question. How might the selection process be different for astronauts to Mars than for quote-unquote regular astronauts?
Well, so far it's going pretty well. We just had 18,000 applicants we're going to go with the class of 2017. So kind of down to 100 in the selection. So I think we'll have no shortage of candidates, which is good news. It's even harder than getting into race. One of the only things that's hard, exactly.
What makes you well qualified?
What makes you well qualified? So what makes it is, but we're not going to change the standards. What makes the astronauts? I think we do a pretty good job right now of of selecting them. So majority of them are from, well, they all are from STEM fields, you know, the majority are actually, you know, engineers, but it's cross disciplines, medical doctors, military folks, right, all that experience. But things that are really important, teamwork, how well do you get along with others? Leadership, but how about followership? Because you know, you four are locked up into something smaller than your bathroom for this, you know, 3.5-year mission. So team dynamics, psychosocial interactions are hugely important. So we pay a lot of attention to that. It's really can't be you know, overstated probably how important the psychosocial issues, interaction, teamwork, being in isolated, confined environments. Great thing is we have analogs of those, and we actually run experiments again internationally with you know, all over the world, you know, NASA and Russia and other places in the world, in isolated, confined environments. We do a lot of work in Antarctica, not surprisingly, right? Because people who went over there. So it's a you know, field of study now, but you do want to select in. You want to select your crew for these very, you know, harsh, isolated, confined environments.
Does NASA foresee that static biology, as microbial engineering, will have advanced enough to play a significant role in the, I guess, the earliest Mars exploration missions?
What was it referred to as we think about synthetic biology? We're on it, you know. I mean, we're, you know, exactly. This is an area too where we have, you know, we pay attention. We have modest investments again because we maybe not, you know, lead in it because what is synthetic biology? Again, back to some of the human health issues and things like that. So we're trying to learn as much as we can about it. Again, universities are really at the forefront. We're pushing it, but so we have, you know, modest amount of grants and look into it. We go to the conferences. What's everyone doing out there? And then we ask, hey, you know, how can that apply to our problems and our issues? So we think there's really great applications. So in case you're in that field, tell us what you're doing. We have fellowships, graduate fellowships, and then how can we use that? We do really look for dual use. How can this, you know, think about helping us for our journey to Mars, and then how can that help people on Earth? So most of the areas in the biomedical areas we think about like that.
Two things. One, moon station or moon base, and the other is scheduled to get boosts on Mars. I think if we advocate our leadership on the moon station, basically to other countries, we're really going to regret it. So I wonder if you have any comment on that. And secondly, this timetable of mid-30s seems so far away, and I'm going to be quite old by the time we get there. I wonder if that's any thoughts on accelerating that? For example, if the SpaceX Dragon lander works, would that tend to pull the schedule in at all?
So great questions, and I get asked them on. So we like the moon to be first and foremost, right? So in terms of our resources and our plan right now, we'll have Space Launch System arrive and be in lunar orbit, and that's why again we're being so upfront about here's all the elements we can afford. This is what's in our plan, but we're saying, hey, who else wants to partner? If someone else comes up with a lunar lander, but guess what we say? Yes, you know, we'll give you a ride. How about a lunar lander? We've got a NASA astronaut on that lander too. So I think people will be on the moon. It's just that we can't lead in all elements of that. You know, we got to move beyond space station. We also can't get stuck on the moon. We want to get to Mars. So, but that's where the international partnership, we think, so we talk a lot about, again, getting to the moon, exploring the moon. Of course, we like the moon. Again, it's not one versus the other, but we have to have Mars, we think, as our horizon goal. So then the question about that you asked about Mars, and we're partnering, and you probably know we're funding the commercial companies right now. Again, their success is our success. And so they can accelerate things. And again, we're not in competition at all, because right now we're funding that. That's good. Now, if some of the private companies, you know, if they have a little bit of competition going on, that's great, because they'll make each other better. So we like that. You know, companies make each other better, perform at the highest level. But then again, if anything can move it to the left and accelerate it, great. But again, you know, we look at it as partnering. So we are partnering. That's a fun thing that got to do in terms of inter-descent landing. We actually are partnering with SpaceX right now for their first attempt. When they get there, probably definitely in the 2020s, they get there. Guess what? that's to take that data. We need to take that data, and again, we're talking up to 20 metric tons, 10 metric tons. Wouldn't it be great to have it at 5 metric tons? You know, we don't have any data on those things, so we need to get all that data. So there's a win-win. So whenever there's a win-win, then we are partnering with our. And wouldn't it be great if there's multiple options for heavy lift launch? We know how to buy services, so to me, that looks like a promising future.
So I know there's lots of questions and I am paying attention, so I know where I'm going, so I'm working on it. We're going to have to call time soon, please.
I have a few questions. So from what I've read, the interim cryogenic propulsion stage will be used for the mission to the moon, but will it be used for the mission to Mars too? And if it is not, then will we use nuclear?
So that's a great question. Jump on our website, NASA.gov, but it's we call them in blocks. We have block 1, block 2, block 3 for SLS, and we build it up again. And you're right on. You know how far do you have to go? And so we take a look at the different blocks in terms of how much payload, first of all, can we carry, as well as how much power we need out of SLS. So we build it up with block 1, 2, 3. And I showed you a video on Exploration Mission 1 in 2018. Exploration Mission 2 is early 2020s. Then we have EM3, 4, 5, 6, 7. This fills out the entire decade of the 2020s with these EM missions. And then we upgrade, if you will. So we do get to a different version of SLS that gets us to Mars, but that's a decade out.
Okay, so quick question. The discussion of the moon has come up a couple of times. So we're talking about Mars and the mission to Mars, but the question is propulsion. And right now there's discussion of moon villages and the mining of helium-3 on the moon for fusion propulsion and for higher levels of propulsion. Where does NASA stand on this? Because it seems to me that going to the moon on the current trajectory, going to Mars would not work without that type of propulsion.
So again, we're aware of those again, and you said, plan. You said actually, I think you said plan or the Moon Village proposed by ESA. There's zero funding for it. John is he's wonderful. This is a close caller, right? It's the vision. It's the right vision to what he can do with the European Space Agency, to look further out. But there's $0 for it right now. That doesn't mean that. Yeah. So we have to. It's tough, and the propulsion. If someone invests in that propulsion and it's ready to go, guess what? Again, we'd love to use it. But my point is, we can't pay for everything. So we have to make critical investments, as hard as it is, and say you can do this and this and this, and if that propulsion is successful, and we're looking now to raise. We're talking about commercialization of low orbit. Guess what? Start small. Some of the private folks see people, vehicles first, and before people, but humanity will be on the moon as well. So we're interested in partnering, not doing it all ourselves. We're interested in partnering, but again, we need other folks to step up to leadership roles too. What are they going to lead? What elements are they going to fund completely? And then we love to work together because we're trying to be really clear about what we can afford and what we can fund. And if we get one lander, well, I'd like that lander to be on Mars. Okay.
3 more questions. 1, 2, and 1 at the other side.
Hi, I'm right there.
Oh, yeah, great.
So step 2 of your mission to Mars is these closed-loop life support systems. So I was wondering if you could talk more about what sustainability concepts that go into that, because I feel like that has a high degree of sustainable aspects, stuff that has to be automatic.
So that's what we need to do in phase 2. Exactly. How can we get the life support system, the closed-loop life support systems, but get them 100% closed? How do we do that? And we do need some new technology to do it. I actually think we should look at some biologicals as well. We can't use the same technology that we use today on the space station. We need to make those investments on what can we do. And again, we need to test them out. It's critical in deep space because that's a more realistic environment. Then you know that you've done the tests for Mars. So not easy, but it's right up on our high priority in terms of technology investments to take a look at those advanced life support systems. They've been on the drawing boards for a while, but we really need to invest in some of them to improve them.
Here's the last one.
And close the loops completely. we're getting there, but we don't have a coach yet.
So SpaceX is talking about unveiling their new BFR Blue Freaking rocket next or this month, I think. And I know you mentioned that you could buy a ride on that if need be. So I guess my question is, how would that compare to the government mandated space launch system if they, and it's a big if they succeeded and had a more viable heavy lift vehicle?
It'll be, the way I look at it, again, I hope it happens. We partner, we're working together now, we're depending on SpaceX, again, we're investing in, they're taking our cargo, they're taking our crews, and we want them to succeed. You're going further and going to Mars. Again, wouldn't it be great if there's two, there'd be great if there's 3 or 4 heavily launched capabilities in the world. Again, so we look at it as, again, in terms of success, and then again, you think about changing the model, services versus crew and astronauts. So we love it. Right now there's 0 heavily launched capability except for SLS. So we have 1. We have 0.8 we're demonstrating, and we'll fly in 18 for sure. And so 2020 is really promising. This is when some of these things come to fruition. And hopefully we can talk about multiple capabilities. Today we can't.
Thank you. So the last question.
Hi. Can you comment on the Mars volunteer program? What's your opinion on such a volunteer program?
So I can't hear it because it's breaking up.
The Mars volunteer program.
Mars volunteer program?
Mars One.
Oh, Mars One?
The private one-way trip to Mars?
Yeah. Like
I think it means Mars One.
Great vision, because it talks about Mars, and that's what humanity is. It's not credible. I mean, technology is not there yet. Expertise is not there, and there's no funding.
So I apologize for all of you who wanted to ask a question. I'm really sorry. I have to be. It's been a long day for Dava, and I think that you sort of enjoyed the benefits of our time here with us, and we're really grateful that she's here. I know you already applauded again, but let's do it one more time. Thank you.